Okay, the lesson is finding the equation of a perpendicular line. Both any perpendicular line and a specific perpendicular line. Let's see the difference. So first of all, what's a perpendicular line? Well, on the graph you can see a blue line there, and the gradient of that blue line is 2. Now perpendicular means at 90 degrees to. So here is a perpendicular line on the graph. What's the gradient of the black line? If we just pick 2 points, to get from the left hand point to the right hand point, I need to go down 2 and across 4. So the gradient is -2, that's a change in the y direction, divided by 4. So the gradient's -1/2. And if we take the original gradient of the blue line, which was 2, and multiply it by the perpendicular line, -1/2, we get -1. And that is true of perpendicular lines. If you multiply their gradients, you always get -1. 2 times -1/2 gives us -1. Here's another example. The gradient of the blue line is 3, and here's a perpendicular line. What's the gradient of that perpendicular line? Let's pick 2 points on it. To get from the left hand point to the right hand point, in the y direction, I'm going down 1, in the x direction across 3. So the gradient is change in y, -1, over change in x, which is 3, and that's -1/3. So the original gradient, which was 3, multiplied by the gradient of the perpendicular, -1/3, does indeed give us -1. So that's a fact about the gradients of perpendicular lines. Now, in order to find the equation of a perpendicular line, it's quite straightforward. You've got 2 things just to do. Step 1, switch the coefficient, that means the number of x and y over, and step 2, change the sign of one of the coefficients. So, in our line y equals 2x subtract 5, switch the number of x and y over, switch the coefficient of x and y. The coefficient is the number in front of the y or the number in front of the x. So the 2x swaps now with the y and becomes 2y, so the coefficient of x is 2. We now make that the coefficient of y, and the coefficient of y originally was 1. There's a 1 there in front of the y. That's now the number of x. So by swapping over the coefficients, and then the second step, change the sign of one of the coefficients, i.e. both these are, that's +2, that's +1. If we change one of those, and I've changed the 2y to -2y, you'll find that this line is now perpendicular. Here's a second example. Remember, switch the number of x and y, the coefficients of x and y over, and then make one of them, change the sign of one of them. Excuse me. So 2y plus 3x, swap the number of x and y over, and that becomes 3y plus 2x. And now make one of them negative. So I'm going to make the 3y minus 3y. I could have made the plus 2x minus 2x. What I don't want to do is change both of them. I only need to change the sign of one of them. And now we have a perpendicular line. Now, in this example, we've got something a little bit different because as well as wanting a perpendicular line, it has to be a perpendicular line that passes through a specific point. The steps that we did before stay the same. We swap the number of x and y over. So 1y equals 2x up here becomes 2y equals 1x. We then change the sign of one of the coefficients. So I've changed the plus 1x to minus 1x. Now this line has to pass through the point 2, 3. Okay, so when x is 2, y is 3, so we substitute those values into this part of the equation. So 2y becomes 2 times 3, and minus x, because x is 2, minus x becomes minus 2. So we end up with 2 times 3, which is 6, equals negative 2, which of course it doesn't. So we have to do something to this right hand side to make the two things equal. What do we need to do to negative 2 to make it add up to 6? And the answer is we need to add 8. So in fact, the perpendicular line that we want is 2y equals negative x and then plus 8. Here's a second example. Switch the x and y over, so 2y equals 3x becomes 3y equals 2x. Make one of them negative, so I've changed the 2x to minus 2x, and now we need to substitute these values of 1 and 4 into our equation. So y is 4, that's why it's green to go with the 3y here. X is 1 to go with the minus 2x there. So our equation becomes 3y becomes 3 times 4 equals, and minus 2x becomes minus 2 times our x value, which is 1. Now we have here 12 equals negative 2, which clearly it doesn't. So what do we need to do to negative 2 to make it up to 12? We need to add 14. And so our actual equation is 3y equals negative 2x plus 14. And finally, in example 3, switch the x and y coefficients over. So we've got 1y and 3x, so we swap those over. So that becomes 3y plus 1x. Change the sign of one of the coefficients. So plus x I've switched to subtract x. Now I'm going to substitute the values in. When x is 3, y is 1. Substitute those in, so 3y becomes 3 times 1. Subtract x. This subtract x now becomes subtract 3. And what do I end up with? I end up with 3 subtract 3. What must this be on the right hand side to make the equation true? It must be 0. And therefore, in actual fact, my equation is simply 3y subtract x equals 0.